students, in this video we are going to study the importance of obtaining the test statistic for the difference between two means by statistic by describing the mean difference and standard error of mean difference. Test statistic. Test statistic is an important fourth step in statistical procedure. Here the t-test statistic value is to computed from the formula. It is obtained from the sample mean of the respective population. The test statistic is referred as sample t statistic. It is obtained from the population because it describes the characteristics of the population. There is a different types of t-test statistic which is obtained from the sampling distribution. The t-test statistic will determine the average difference between the two groups. The appropriate test statistics for the different sample t-test is given by t equal to x bar minus y bar whole divided by square root of s square into 1 by n1 plus 1 by n2, which follows t distribution with n1 plus n2 minus 2 degrees of freedom. Example. Now we are going to see an example how the test statistics can be executed for two different sample t-test. Here given below is the gain in weights of pigs which are fed on two diets, x before a normal diet and y after a nutrition diet. Gain in weights are given for diet x and diet y are given in observations. Here we are going to test whether the two diets differ significantly with respect to the effect on increasing in weight. Solution. The first step is framing the null hypothesis. Here we frame h naught colon mu x equal to mu y. X and y are diet x and diet y. So we frame h naught equal to mu x equal to mu y. That is, there is no significant difference between the mean increase in weight due to diet x and y. Alternative hypothesis is called as h1 colon mu x is not equal to mu y, which may be mu x greater than mu y or mu x less than mu y. That is, there is a significant difference between the mean increases in weight due to diet x and diet y. The third step is level of significance. It may be fixed at 5% or 0.05. Diet x and diet y values are given in the table. So first diet x table, we have the observation of x which are given in numbers. The summation x is given as 336. Similarly, we find x minus x bar, that is always equal to 0. And the third column we have x minus x bar the whole square. The summation value are given as 380. This is for diet x, and similarly we can compute for diet y. In computing diet y, first column we have the diet y variable which are given by 44, 34, 22, 10 etc. up to 21. The summation value is given by 364. Similarly, we can compute y minus y bar and y minus y bar the whole square. The y minus y bar the whole square summation value is given below as 1320. Here we have two sample n1 and n2, both are sample size are equal to be 12. So we consider n1 equal to 12 and n2 equal to 12. Here the summation x is computed as 336. Similarly, we compute summation y 364. Similarly, we compute summation over x minus x bar the whole square, that is equal to 380, and summation y minus y bar the whole square is 1320. We can compute the mean of x and mean of y, which are called by x bar and y bar, which is computed as 28 and 30.33. Similarly, we can compute s square. The formula given is 1 by n1 plus n2 minus 2 into summation over x minus x bar the whole square plus summation over y minus y bar the whole square, that is computed as 77.27. Here a table is given. This table is called by T table. This table you can able to see only in the textbooks at the last page whenever you study about T distribution. This T distribution table comes under twofold. One is for one tail test and another is for two tail test. Here we have to see the degrees of freedom. In the previous slide we say the degrees of freedom is 22. So in the degrees of freedom 22 at 5% level we have to see, so we can obtain 2.074. This is the value we have to check based on the degrees of freedom and the level what we fix. So the level what we fix is 5% for one tail and two tail. One tail we called as 0.25 and 0.05 for two tail. Similarly, we can see the degrees of freedom for 22 and the corresponding value what we called as the table value. In this two sample T dependent test, we can calculate the formula T equal to x bar minus y bar square root of s square into 1 by n1 plus 1 by n2, that is equal to 28 minus 30.33, which are the mean of the first diet A, mean of the second diet, the whole square root of the s square value and the number of samples, which are computed as T equal to minus 0.649, which is called as the calculated value. The table value is obtained from the previous slide. I explained how to find the table value based on the sample size of the degrees of freedom and the corresponding level of significance. So we obtained as 2.074 at T at 5% level, that is T of 0.05 for 12 plus 12, 24 minus 2, that is equal to 22 degrees of freedom. Inference. The last step of concluding the remarks is inference. Since the calculated value of modulus T is 0.649, which is less than the table value of T, that is 2.074. Here the null hypothesis H naught is accepted at 5% level of significance, and we interpret that the two diets do not differ significantly with respect to their effect or increasing in their weight. Inference. The last step in testing procedure is inference. Here the calculated value of modulus T is given as 0.649, which is less than the table value of T, that is 2.074. Here the null hypothesis what we call as H naught is accepted at 5% level of significance, and we interpret that the two diets do not differ significantly with respect to their effect on increasing in weight. Standard error. It refers to the standard deviation of various sample statistics such as the mean or median. For example, the standard error of the mean refers to the standard deviation of the distribution of sample means taken from a population. When the standard error is less, the sample mean is a true representation of the population mean. Standard error. The formula for the standard error is given for the corresponding statistic and the standard error. First we have sample mean x bar. For that we have the standard error is sigma by root 10. Next we have sample standard deviation, that is S. The formula is given as square root of sigma square by 2n. The third is sample variance, that is S square. For that the standard formula is given by sigma square into square root of 2 by n. Let us summarize what we have learned in this video. In this video, we have learned about the importance of studying null and alternative hypothesis for two sample dependent t-test, the merits and demerits of sampling methods and random sampling with normal parent population, the test statistics for two different sample by using standard error. Students, let us meet in the next video. Thank you.